Watch the complete playlist on the app Pions. Download the app now.
Calculate the work done to associate the four charges at the corners of a square with side length r. Now, what students do blindly, okay, because they don't practice, they directly attend the lecture and then they forget. So what they usually do is they'll say that, see, this sir, we have four charges. We can directly say that U1, we can directly find the potential energy between first and the second charge, second and the third charge, third and the fourth charge, and simply add all the potential energies, which we usually do for potentials, right? So what you will do, sir, k q1 q2 by r over formula for potential energy is, since it's a scalar quantity, it will be 1 by 4 pi epsilon naught charge q1 q2 upon the separation between them, right? And sir, first find between BC, then find CD, then AD and AB, and then it's done. No, it's not done like that. Be very careful. Formula is this, but the way we solve it for potential energy, that's a different way. Okay, so you have to be very careful while dealing with potential energy. So right, so what we have to do for potential energy, basically what you will do is, you will first, let's start from any one. You can choose any one of them, and let me start it from let's say A. So I'm putting my first charge at A, okay, here. And what is the magnitude of the charge as per the diagram? Minus 2q. So to put this first charge at this place, you have to do some work? No. Why you don't have to do work? Because there is no one to influence this charge, right? If you are sitting alone in a room, you can't talk with anyone. Okay. Now don't say, sir, I can talk with myself. Okay. Now that's another issue. So here, if you are sitting alone in a room, you are not interacting with anyone. So this charge is not interacting with anyone. So U1 will be equals to 0. Potential energy required to put this charge at this point where there is no other charge will be 0. Now let's go to B. So if I place the second charge B at a distance of r, as per the question, the square has a side length r, and this is our Q. Now when you place the second charge, you have to do some work either against this first charge or in favor of that charge, depending on the signs of the charge, right? If this is positive and that is negative, they both are attracting. If that is both are negative, they will repel, or both are positive, they will repel, right? So if you're placing here, you are doing some work. Now U2 is the amount of work you have to do to place the second charge at that position, and that will be 1 by 4 pi epsilon naught Q1 Q2. Let me remind you once again, potential energy is a scalar quantity, so negative sign is to be taken here in this chapter. Whole divided by r. This is the potential energy required to place this second charge at that point. Now if you are placing the third charge at this place, this minus q, this is the third person entering the room. So this person can interact with this person as well as this person. Now, when I'm saying interaction, I am not saying that they will talk or they'll fight or they'll do whatever attractive, repulsive, whatever is the interaction, but this will interact with this as well as this. So when this is interacting with this, what is the separation here? R. So U3 is the amount of potential energy required to place the third charge at that point. And when you're placing it there, it will be 1 upon 4 pi epsilon naught, the charge first one, the charge second one, whole divided by r. This is the interaction of this with that. Plus, be very careful, plus the potential energy required to place these two charges. The interaction between these two charges. And what is this gap? Sir, if this is r and that is r, using Pythagoras theorem, this will be root 2r, the separation or this diagonal. So separation between C and A is root 2r. Why root 2r? You can use Pythagoras theorem. If this is r and this is r, use Pythagoras theorem, hypotenuse square equal to perpendicular square plus base square. You will get eventually root 2r. And now that will be 1 by 4 pi epsilon naught. First charge, second charge, whole divided by root 2r. You have to be very careful. Now majority of people go wrong here only. That's why I am solving. Because they directly, when they write, this factor of root 2r doesn't arrive. Because everywhere they take this as r, this as r, this as r, this as r. And they directly write it as r, r, r. Root 2r will come only if you are placing the charges one by one, and then only you are solving, then you will get. Let's place the fourth charge over here. Now the fourth person enters the room. Now this person will interact with all the three, maybe attractive, maybe repulsive, depending on the signs. But when it is entering, it is interacting. And you have to do some work when you are placing it against all three. So potential energy required to place the fourth charge will be interaction of this charge with the A charge. Let's put it here, 1 by 4 pi epsilon naught. 2q is the charge which we are placing, minus 2q it is influencing upon the separation between both, which is R. Then interaction of this with the B charge. So this is again diagonal, right? Square diagonals equal root 2r. So this will be 1 by 4 pi epsilon naught. The first charge 2q interacting with q whole divided by root 2r. Finally, interaction with the third charge, which is C. So it will be 1 by 4 pi epsilon naught. First charge 2q, second charge minus q whole divided by how much? R. So which one is the correct answer? So you have to add all of them. Okay. So the total potential energy required to assemble all of them together will be U1 plus U2 plus U3 plus U4. Sorry. So let's put here U1. What's our U1? Sir, 0. Be very careful with the signs. Now minus into this will be minus 2q square upon 4 pi epsilon naught R. That is U2. U3, q and q minus q square upon 4 pi epsilon naught R. Minus minus plus 2q square upon 4 pi epsilon naught root 2R. Done with the third one, U3. Fourth one, U4. Minus minus 4q square upon 4 pi epsilon naught R plus 2q square upon how much? 4 pi epsilon naught root 2R. And how much here? Minus 2q square upon 4 pi epsilon naught R. Correct? So these are our parameters. Now let's simplify it further. So this, okay, minus 2q square and minus 2q square. Which one? This one and this one. So 2 and 2 is, because they are same. Even R here, and 2q square. Minus 2 and minus 2, minus 4q square by. So let me write here. The final energy is minus 4q square by 4 pi epsilon naught R. Okay, how I got 4q? Again, I am repeating. See, this is 1 apple plus 1 apple. It will become 2 apples. So multiply this parameter with 2. So you will get minus 4q square. Correct? Next, let's move to any other R parameter. Yes, here it is. So this will be minus q square and minus 4q square. How much it is? Minus q square and minus 4q square. Minus 5q square. Let me write here minus 5q square upon 4 pi epsilon naught R. Correct? Let's move ahead. Then we left with this root 2 parameters like root 2R here and root 2R here. So 2 and 2, 4. So here 2 and this 2, 4. 4q square by 4 pi epsilon naught root 2R. Correct? Great. Now 5 and 4 minus minus plus. So minus 9q square upon 4 pi epsilon naught R plus 4q square upon 4 pi epsilon naught root 2R. Now what we'll do? Sir, now you can take q square, which is common in both, 4 pi epsilon naught R, which is common, and what we left with minus 9 by 4 plus 4 by root 2. You can leave it like this. This is our total potential energy to assemble group of 4 charges at the corners.
Watch the complete playlist on the app Pions. Download the app now.